Hello everyone. So today we're going to go over section 6.4, Trigonometric Equations. So with trigonometric equations, we're usually looking for the value of an angle, usually denoted as theta. The solutions may need to be in radians or in degrees. That will usually be stated in the question itself. So let's look at example number 1. It says solve cosecant theta is equal to 2, where theta is between 0 and 2 pi. And it says to give the solution as exact values. So we know that cosecant theta is equal to 1 over sine theta. So we have instead 1 over sine theta is equal to 2. So in other words, isolating for sine theta, we know that sine theta is going to be equal to 1/2. So sine theta equals 1/2. We know that the trig ratio is positive. So this is going to be in either quadrant 1 or in quadrant 2. Okay. The second thing that we know is we have 1/2. So using the spectral triangle, actually just going to go ahead and draw that in here. Look like this. And in quadrant 2 will look like this. Let's go ahead and draw in the special triangle here. We're looking for the opposite side to be equal to 1/2 in both cases. So, of course, that means that the adjacent side will be √3 over 2 in quadrant number 1, and negative √3 over 2 in quadrant number 2. Okay. That's just a bit of added detail. What we really needed was the reference angle, which, of course, in both cases is going to be pi over 6, or 30 degrees if we were working in degrees. Okay, so then the third step then, in quadrant 1, of course, we just have theta 1 is equal to pi over 6. And then the second angle is in quadrant 2, and the reference angle is going to be pi over 6. So we have theta 2 is equal to pi minus pi over 6, which gives us 5 pi over 6. Okay. So looking at the diagram here, we know that this angle here, that's pi over 6, and this angle on the left is also pi over 6. So the actual angle is going to be pi minus pi over 6. So we have 5 pi over 6 as the second answer, whereas pi over 6 will be the first answer. Okay. All right, so that's kind of the idea. And we have found both the solution that's going to be between 0 and 2 pi. So what happens if the solutions are not restricted to a particular domain? So if we look at example 2 here, we have the general solution in both radians and degrees, and that's a new idea or new concepts. So let's look at how this works. First one, we have cotangent theta, square root of 3 cotangent theta minus 1 is equal to 0. So we'll begin with square root of 3 cotangent theta is equal to 1. That means cotangent theta is equal to 1 over the square root of 3. Using the reciprocal of cotangent theta, we have tangent theta then must be equal to just the square root of 3. Okay, so from here we know that the angle must be in either quadrant 1 or 3, because that's where tangent theta is positive. So Q1 or Q3. Second step, we're looking for the reference angle. So the reference angle is going to be, let's see here, if we look at, once again, the the special triangles we can draw. Be like this way. So we have y is equal to root 3 over 2, and x is equal to 1/2 if it's in quadrant number 1, and in quadrant number 3 we will have negative 1/2 for the x value and negative root 3 over 2 for the y value. So the quotient will still be positive. So the reference angle then here, if we use the special triangle, that would just be pi over 3, or 60 degrees if, once again, we're working in degrees. So from there, we know that the first answer is going to be pi over 3, and then the second answer will be pi plus pi over 3. Which of course is 4 pi over 3. Okay. Now, in terms of degrees, pi over 3 is 60 degrees, and 4 pi over 3 is 240 degrees. If the question were just asking for the solutions in both gradient and degrees, that is what we'll have. However, it actually asks for the general solution. So notice that the first answer is pi over 3. The second answer is the same pi over 3 but added pi. So if we go half rotation around, we'll end up at 4 pi over 3. And then if we add another pi, we'll end up at pi over 3 again, but we would have completed a full rotation, and so forth. So that is to say, we can keep on adding multiples of pi to reach another solution. And those solutions will, well, the pi over 3 and the next iteration of pi over 3 will be coterminal to each other, and the 4 pi over 3, and then we add 2 pi to that will be coterminal as well. So combining those two statements, we'll have pi over 3 plus pi n, where n is an integer, to encompass all of the solutions. And of course, we can also have the same thing in degrees, and that will be 60 plus 180 degrees times n, where n is an integer. What is tricky is, because tangent theta is in quadrants 1 and 3, the solutions are 180 degrees apart. So we can continue to add 180 degrees and get the next solution. That is not the case with sine and cosine, because the solutions will be in quadrants 1 and 2 for sine, and quadrants 1 and 4 for cosine, assuming they're positive. So the same thing doesn't quite work, and we'll have to do something slightly different. Okay, but we'll look at that as well. So here we have negative 4 plus 5 cosecant theta is equal to 4 cosecant theta minus 5. And so the first thing we can do here is we can subtract both sides by 4 cosecant theta. And that will simplify the equation to negative 4 plus cosecant theta is equal to negative 5. And then therefore, cosecant theta is going to be equal to negative 1. And again, taking the reciprocal of both sides, we'll have sine theta is equal to negative 1. Okay. So that simply means that the y value is negative 1, and that really only happens in one place, and that is if the line is drawn straight down. And that's how we get this negative 1 0, -1. So therefore the angle must be in degrees 270 degrees, and in radians 3 pi over 2. Okay, so theta is equal to 270 in degrees, or 3 pi over 2 in radians. To generalize these solutions, notice that the next solution will be 360 degrees away, so the general solution in degrees will be 270 degrees plus 360 degree multiplied by n, where n is an integer, just to capture all the coterminal angles. And then for radians, we have 3 pi over 2 as the principal angle, and then we'll add 2 pi multiplied by n, where n is also, once again, an integer. So in general, we are going to be adding 360 degree n and 2 pi n for cosine and sine questions, and pi and 180 degrees for the tangent question, just because of what quadrants the answers can land in. In future units, we'll be looking at how to change the period, so there will be the solution may be more frequent or less frequent, but for now, we're just going around the circle of 360 degrees. Okay, so let's look at the next question. Right, so in this case, tangent theta is equal to a decimal approximation, -0.1234. And we're looking for theta in the domain from -2 pi to +2 pi. So if we kind of look at the diagram for this, first of all, tangent theta is negative in quadrants 2 or 4, so it's going to look like this. Okay, that's the first step. Okay, so to summarize here, tangent theta is less than 0, which means this is going to be in quadrants 2 or 4, so that's what the diagram is showing. Okay, so in order to find out what these two are, it's probably best to use the reference angle. So we're going to set it as tan theta r, the reference angle, is equal to +0.1234. So theta r is going to be equal to approximately 0.1228 using a calculator. So from there, we can find out what the actual angles are. So the quadrant 2 answer is going to be pi minus 0.1228, and the quadrant 4 answer is going to be 2 pi minus 0.1228. Since the reference angle is 0.1228 going this way, and in quadrant 4, that's the reference angle. And as always, the angles and center positions are to be drawn in the counterclockwise direction. So that will already give us two answers. The ones that are, let's see here, the first one will be, again, approximately equal to 3.0188, and the other will be 6.1604. However, the question does ask for solutions from -2 pi to 2 pi, and we actually only cover the solutions from 0 to 2 pi. So in order to get the other two solutions, we also need to consider what happens if we have -pi minus 0.1228 to get this answer here, but another rotation in the negative direction. So think about it as we start here and then we go all the way around the circle once. Or actually, that's not what we're doing. We're going this direction to get the third answer. So that would be negative pi minus 0.1228, which gives the third solution. That would be negative 3.2644. And that's the third answer. And finally, the last answer will be, again, starting at the 0, going clockwise all the way around, and then a bit more. Actually, that's not the case, is it? No, sorry. It's just it's just starting at 0 and going clockwise. Sorry about that. That's the fourth answer. So that will be 0 minus 0.1228. So that's, of course, it's just negative 0.1228. Which makes sense if there is two solutions going from 0 to 2 pi, and that's angles 1 and 2. There should also be two solutions going from negative 2 pi to 0. So that's the question. The answers 3 and 4 are with this first part here, and then answers 1 and 2 are with the second part. Okay, and of course we expect theta 3 and 4 to be negative because it's somewhere between negative 2 pi and 0. Okay, next part. Right, just to summarize or reiterate what we looked at in this question. First step is to determine what quadrants the solutions will be in based on the fact that tangent theta is negative. That's what we did first. Second thing is to use the positive value to determine the reference angle using a calculator in this case, because negative 0.1234 is not a special triangle number. And then from there, we use the fact that the reference angle is 0.1228 to find solutions 1 and 2 in the second rotation here, and then solutions 3 and 4 in the rotation before that. And that's a summary of what we did. Next up is factoring. So we're going to combine trigonometric equations with some factoring here. It's important to know that sine theta times sine theta can be written as sine theta in parentheses all squared, or sine square theta, but not sine theta squared, because that will mean that the angle theta has been squared. Okay, so here we have a few examples. Let's start with this one here. So we can start with moving the 6 to the right-hand side, and then dividing both sides by 3, and then taking the reciprocal of both sides. So we have sine theta is equal to 1/2. Okay, so from there we know that the angles are in quadrants 1 and 2, or 1 or 2, because sine theta is related to the y value, and the y value is positive in quadrants 1 and 2. Second step is to use the reference angle. So the reference angle in this case will be 30 degrees because the question is in degrees, and we can use a special triangle for that one. So let's go ahead and draw the special triangle to the right here. The 30, 60, 90 triangle. So here is 60 degrees, sorry about that. Here is 60 degrees, 30 degrees at the top, and 90 degrees here. The hypotenuse is 1, this side is 1/2, and here we have √3/2. So if sine theta is equal to 1/2, then opposite over hypotenuse is 1/2, so we have 30 degrees here. So the reference angle is 30 degrees. So from there, then the first angle is in quadrant 1, so that's just 30 degrees. The second angle is going to be theta 2, and that's going to be 180 minus 30 degrees. The reference angle is 30 degrees, and it's in quadrant 2, so it's 180 minus 30, which is 150 degrees. Okay. So both of these solutions are in the domain from negative 180 to 180, and there's no other solutions because if we think about it, just a quick diagram here, this is 0 to 180 going this way, and 0 to negative 180, which is in the other direction, but that only covers quadrants 3 and 4, and there are no solutions there. So the only solutions, once again, are just going to be 30 degrees and 150 degrees. Okay, so let's move on to the questions with the quadratic components. Once again, here we can just factor. So we have cosine square theta minus 3 cosine theta plus 2 is equal to 0. So we can treat it like a quadratic equation. We have cosine theta minus 2 times cosine theta minus 1 is equal to 0. That, of course, means either cosine theta is equal to 2 or cosine theta is equal to 1. Now, what is important to note here is that cosine theta cannot be equal to 2. Cosine theta is between negative 1 and 1 only. So there's no solutions here. However, cosine theta equals to 1 does give us solution, and then here the theta is going to be equal to 0. Right? X equals to 1 around the circle only when the angle is 0. And that will be the only solution from negative pi to pi, so we only have one solution here. That's it. Just really quickly as well, just a quick aside, recall that cosine theta is equal to adjacent over hypotenuse. And on the triangle, or even if we have x over r, the adjacent side cannot be longer than the hypotenuse, so it's never going to be equal to 2, so this is not possible. And that's why for this part, we just said there's no solutions there. Okay, so from there, one more. This time we have, sorry about this. This time we have the tangent ratio. Again, we can factor, so this will be tangent theta minus 4, and then also tangent theta minus 1 equal to 0. And unlike the sine and cosine ratio, the tangent theta could be equal to 4. It could also be equal to 1. So both of these parts will produce solutions. However, notice that tangent theta equals to 4, that is not a special triangle value at all. So the solutions that we're going to get from this will be decimal approximation using a calculator. The first one is going to be in quadrant 1, and the second will be in quadrant 3, because that's where tangent theta is positive. And using a calculator, we get theta 1. That's going to be equal to 1.3258. Again, that is an approximate value. Theta 2 we can get by using the first answer as a reference angle. Since it's in quadrant 1, it also doubles as the reference angle for this question. And since the second solution is in quadrant number 3, we have pi plus the reference angle of 1.3258. And that's going to give us the approximate value of 4.4674. Okay, and those two answers are both between 0 and 2 pi. Next part we have, just going to use a different color here. Tangent theta equals to 1. So tangent theta equals to 1. This is a special triangle value, but we do have, again, quadrant 1 and quadrant 3. Since tangent theta is positive, the first angle would just be pi over 4. And the other angle is going to be pi plus pi over 4, and that will be 5 pi over 4. So in some questions, such as this one, there will be a combination of decimal approximate answers and also exact solutions. And it's important to recognize when is it possible to have each one. And that's it for the trigonometric equations part of this unit. And so thank you for listening.